We should see smiling faces in the morning.
Yes.
Yeah, so now many people are there. Please take the screenshots, co-host. Okay, so you can make your video off now. Thank you. So we are having our resource person right now, so we can start. Let me first introduce our resource person. Just give me a minute. So good morning, everyone. We are starting our first session of today. That is the third day. Today we are having with us Professor H.Ramananda Singh, who is the head of the Department of Business Administration, Assam University. He is having a 24 years of teaching experience and 2 years of industry experience. Professor Ramananda Singh's area of interest has been general management, marketing management, and quantitative techniques. He is an alumnus of BHU and Lucknow University. He has been continual in teaching research methods and quantitative techniques in the department since long. Professor Ramananda has 32 number of paper publications in referred journals, 4 number of book publications, 9 publications in edited books, etc., and couple of dozens of national and international seminar presentations. Apart from academics, he had been the director of UGC HRDC, formerly known as Academic Staff College, Manipur University, for 5 years from 2014 to 2019. And he is also my teacher when I was a student. So I welcome you, sir, in today's session, and the session is all yours.
Thank you very much, Dr. Divjyoti. Thank you very much. It was a nice introduction. My dear friend, good morning. So good morning to you all. I suppose that you have been muted. Okay, no problem.
Yes, sir, they are muted. So if you tell them to be interactive, so I will make them
Okay,
on
no.
for everyone. How you would like to be, like whether
It's okay, it's okay.
Okay, sir.
So many participants were there, so you will let them mute. Okay, they can send in the tool. If any questions, they can send it through chat.
Yes, sir. Yes.
So good morning, everybody. So I have been given the honors or responsibility of taking certain basic, statistics. And also I have been told that I should be teaching all the theoretical aspects, what we have done manually a long time back. And not to touch SPSS part, because SPSS part we'll be discussing in the next program. So I was recollecting before SPSS what we have done, and then theoretically, because we found that many research scholars they're conducting the research work, and using SPSS without understanding under what condition, under what situation these SPSS are to be used. But if we know theoretical aspect, then these silly mistakes may be overcome. So I remember my first article was published in Indian Journals of Marketing in 1996. There was based on the economic development and educational level and economic development of India. So I use correlation R, then the t-testing, and then the probable error for testing significance. And I was very much happy. Later on, I realized that some of the process, what I did was wrong. So in due course of time, we learn. Still, if I got a chance of attending some training programs, I do attend the programs. So knowledge is not perfect. Even many questions on research are still lurking in my mind. Some I have got answers, some still lurking in my mind. As in when I got a chance of interacting with the senior people, I asked them, sir, why is this? Why is this? So some answer convincingly, some of the answers I'm not satisfied. Still, I'm trying to solve those questions regarding research lurking in my mind. Now, most of you who are young teachers, you may also be having some questions in your mind. Why this is technique here and why this is not technique is not here, and so on. So in due course of time, on your own, or by listening to some of the experts delivery, some of the answer maybe some of the questions may be answered, but still we have a long way to go. We started our research work during those days when we don't talk about the SPSS. Now so many techniques are coming. Status, this, then the SPSS, R technique, AMOS, and so on. So many things, the econometrics. So many things are coming up. So we have to unlearn the past things, and we have to learn again. So even though I have become professor long time back in 2010, still I'm attending some of the programs on research methodology to enrich my knowledge on research. Still, many things I don't know. Whatever little thing I know, I would like to share with you so that you may not be making the same mistake that I made. So to begin with, let me show the slide. Devo, is it visible?
Yes, sir. Visible, visible, clear.
But my picture is not visible here. Okay.
You have closed your video mode, I guess.
Close video. I'm not seeing myself on the screen. Where to go?
Sir,
Sir, sorry to interrupt, sir. Sir, I think you just share the screen. You just again just stop the share the screen, sir. Please click on stop sharing. Yeah, thank you. Now you click on the share again. There's a three options: basic, advanced, and filter. You just click on advanced, sir.
Where? Advanced. Oh.
Yeah, there's an advanced option. And there's a first option is PowerPoint as a virtual background. First option.
But this one is blurred.
So you using the
PowerPoint.
MacBook or Windows?
I'm winning in window.
Windows, no? Okay.
Hmm.
So we have an option PowerPoint in a you if you click on the advanced now. So there is an option is PowerPoint as a virtual background. You just click on it and just click.
This become blurred.
No,
This
no,
is
no.
blurred. Others are portion of screen, then music, these are okay. Content from second camera is okay, but this portion, PowerPoint as virtual background is blurred. It cannot be clicked.
Okay, okay, it's not an issue. You just single click and just click on the share. You just click on the icon of PowerPoint as a virtual background and then just click on the share.
But this portion is with them blurred. Okay. I'm listening.
Please, please. Now it's visible, sir?
So my screen is visible. Okay.
Is visible to you, sir?
Where the screen is visible, screen, my
So,
PowerPoint.
yes, sir. We can visible, but you can visible na your screen.
I can see the screen myself as well as the PowerPoint.
Okay, okay.
Is
Thank
it
you, thank
PowerPoint
you.
visible? Or
Yes, sir.
then
Yes,
I can
sir.
proceed.
Yes, sir. It's visible, clearly visible. So
So, my
perfect,
dear
sir.
friends, so well, even these new online things we are learning. So, and all else, we know you will be learning so many things. So, I'll be covering this aspect. Uh, I was informed that first part, basic statistics, so many things in 2 hours. So those which are relevant with the research work and along with the examples I'll be covering. The first one is measure of central tendencies. Dispersion, correlation, test of significance and its need, and the terminologies used in hypothesis testing. 2 hours time has been given, and I will not be using the spaces. What I have to mention is in brief about these things are important. Those which are important for the research work. Because in the research work you're making descriptive, one table where you have to produce, you have to mention the descriptive statistics before going for further analysis. There, you're in need of a measure of central tendencies. Then again, in research work, often for quantitative data, and you'll be talking about correlation R only. Comparison or mean correlation R. Regarding the quantitative data, nothing else will be talking in research, only correlation R and the background, where you will be needing this measure of central tendencies and where you will be needing this test of significance. Now, is it audible, Deepak? Clearly audible?
Yes, sir. Audible. Audible.
Okay, okay. So after collecting the data, you'll be assembling the data. Then bring the data into order by, you'll be making the tabulation, you'll be making the classification of data like male, female, and then you'll be making bringing the data into order means you'll be making the tabulation of the data, and then you will be making the categorization. Then summarizes the data, estimating median mode and percentage. So often we make estimating mean, often we make percentage. And then after that, you have to select the appropriate analytical tool for testing the hypothesis. Appropriate. After summarizing the data into order, after summarizing the data into order, select the appropriate analytical tool for what? Examine the difference in the mean. Analysis the experimental data, your F test, then measure of association, testing the correlation R. So here in the summarization of the data into order, you should know the descriptive statistics. The descriptive statistics here are measure of central tendency and dispersion. Clear? So you may be collecting the data by experimentation, or you may be collecting the data by observation, or you may be collecting the data by questionnaire. Assemble the data, then bringing the data into order. Now you make a tabulation, categorization of the data, then summarize the data into order. Here you require descriptive statistics. This is the measure of central tendency, and you require the dispersion, the standard deviation. Clear? After that, you'll be selecting the appropriate analytical tool for examining the difference. Is there any significant difference between the male and female in terms of anxiety? Is there any significant difference between the male and female in terms of stress of the teachers and so on? Analysis of experimental data or measure of association here. Now, after this, you'll be selecting the appropriate tool. What is the analytical technique intended to do? What is Z test intended to do? What is T test intended to do? What is the chi-square intended? You should understand that. What is the analytical technique intended to do? The scale in which the data are measured.
Sorry to interrupt you, sir.
Normally is, scale. We have nominal scale, ordinal scale, interval scale, ratios. Yeah.
Sorry to interrupt you, sir. Sir, if it is possible, you just
Yes.
switch off your
Deputy.
camera, sir, camera. So it will your audio is properly audible to us, because now sometimes your voice is not audible to us. So I request you kindly
Okay,
please
okay.
switch off your camera, please.
Okay. Is it okay?
Yes, sir.
Yes,
Now,
sir. Perfect, perfect, sir. Please go
Now,
ahead, sir. Thank you, sir.
so there are so many tools. You have parametric statistics, non-parametric statistics. Now, what is the analytical technique intended to do? The scale in which the data are measured. On which scale you have measured, interval scale, ratio scale, and then whether your technique is parametric or non-parametric, number of variables to be analyzed, dependent, independence, number of samples to be analyzed. These are the conditions. After knowing this condition, then you are ready for applying the statistical tools. First of all, summarize the data using the measure of central tendency and dispersion. Then you choose the technique. Either it may be Z-test. Then you go for analysis. So your measure of central tendency is a must. You should know it. Nowadays, by simply clicking the button, you'll get a limiting mean. You will get a standard deviation. But in those days, what we do and what are the different forms of data we need to discuss. One thing you should know very well that one of the most important objective of statistical analysis is to find one single figure. Your Z-test is also one single figure. Your T-test is also one single figure. Chi-square also gives you ultimately one single figure. Now, one of the most important objective of statistical analysis is to get some, few single figures. From there, you have to extract the meaning. From there, you have to after taking the important information, you have to take a decision. The purpose of statistics is not to give you many data, unorganized data. The purpose of the statistics is to give you one or two single figures which are organized, which are derived from those unorganized data. From that, you have to draw the meaningful information. So let me introduce. To measure of central tendency is the first topic that was given to me. One of the most important objectives of statistical analysis is to get one single figure value that describes the characteristics of entire mass of unwieldy data. Unwieldy means unorganized data. Such a value is called the central value or average or expected value of the variable. Now, so when somebody asks you how much mark you got in matriculation, you simply say 90%, 80%, 70%. You never said that in English I got 80, then in mathematics I got 90. You never said. Well, when somebody asks you how much you got, you simply say 80%, 90%, and that is the representative of all your marks of different papers. Likewise, in statistics, you have so many data which are unorganized, but from that you can't draw any meaningful information. To draw meaningful information, we have to get a single figure from that mass unorganized data, and that value is neither the highest nor the lowest value of the series, but somewhere between these two limits, lowest or the highest, possibly in the middle. For this reason, average is frequently referred to as measures of central tendency. Average. Arithmetic mean is not only average. Mean, median, mode, harmonic mean, geometric mean are also average. For this reason, the average, which is representative of the large unorganized data, is called average, and this is also called central value. So remember that one of the most important objectives of statistical analysis is to get one single figure value. Clear? It may be arithmetic mean, it may be mod, or it may be chi-square, it may be z, it may be t. So there you get one single figure. From that you have to draw meaningful information. Now, an average is an attempt to find one single figure to describe whole figure. As I told you that when we ask you how much you got, you simply say 80%. You never said that in one paper I got this much, in another paper I got, you never said that. You get the single representative, that is the average. So objective of averaging is to get single value that describes the characteristics of the entire group. And after that it facilitates comparison. Oh, you got 80%, he got 95, oh, 5% more. So he's a better person. So by looking at the average, it helps us in comparison. It facilitates comparison. Now, there are 5 measures. See, arithmetic mean, median, mode, geometric mean, harmonic mean. earlier. But often you'll be talking about arithmetic mean, median, mode. So I'll be covering these three. Now, knowing how to calculate is very much important, but when to calculate, when to use arithmetic mean, when to use median, when to use mode is more important. So wrongly using arithmetic mean where you are supposed to use mode, then this will lead to the fallacies of your research finding. Let me tell you a small story, my old story. So I used to narrate to my students that there is a person, there was a small village. They go to the big market after crossing a river. So one day what happened is that during that time there was a mela going on in the city. So many people from the villages are going to the mela and they're returning home by boat. So they have to cross the river. So what happened is that the person wants to reach home by 6 o'clock. But what happened is that because of the mela, all the ferries are so many people are crowded. He has to wait for another 3-4 years to reach home. But he wanted to reach home, reach his home in the village by crossing the river as soon as possible. Then he asked the ferryman, how much depth is the river? Another ferryman says that somewhere it is 3 feet, somewhere it is 5 feet, somewhere it is 8 feet, somewhere it is 10 feet, somewhere it is 2 feet, something like that. Then he finds the average and it comes out to be 5 feet. All right, I am 6 feet tall, and the average height of this depth of this river is 5 feet. I can easily cross the river. So he go to the river, he get drowned because in the middle the maximum there was 10 feet. So he had wrongly calculated arithmetic mean. There he should have calculated more maximum depth. What is the maximum depth? The 10 feet, my height is only 6. It will be very much difficult to cross the river by walking. But he had calculated arithmetic mean, and arithmetic mean comes out to be 5 feet, and this guy was 6 feet tall, and he thought that I can easily cross it, and he entered into the river and get drowned. So wrongly using the measure of central tendency, so the person led into problem. So we should know when to use arithmetic mean, median, mode. But one of the good book, one good book or foreign book might be Marketing Research by Herbert W. Boyd. There it was mentioned that if the data is collected on the nominal data, calculate mode. If the data is collected on the intervals on the ordinal scale, calculate median. The appropriate average is median. And if the data is collected on the interval scale, then arithmetic mean. And if the data is collected on ratio scale, then geometric mean is the most appropriate measure of central tendency. Now, when you collect the data on Likert scale, like strongly agree, disagree, then the neutral, somewhat disagree, somewhat disagree. There, people say like this: 50% of the people say strongly agree, 20% of the people say disagree. It doesn't make sense. Then you calculate the median. Median is the representative of all those. So the median average is strongly agree, finish, or median average is agree, finish. Often I come across research scholars say 20% of the people says highly like, then highly dislike, then 20% says dislike, then 20% say somewhat dislike. So from what inference you'll draw from this? Still, it is unorganized. Find the average median, find the median value, and come to the conclusion that since Likert scale is ordinal scale, you apply the median. So the average response is that the average median response is that people like it or dislike it. So one single figure. So often I come across people using Likert scale. They write like this: 20% of these, 30%. Don't do that. Instead, instead of that, you calculate median. Now let us go for arithmetic mean. See, calculation of arithmetic mean. So there are different methods, but I will summarize into only 3 methods only. See, for individual observation, then for discrete maybe discontinuous. For individual observation, discrete series, continuous series. In SPSS, they'll be talking only 2 things: continuous and the discontinuous. While entering the data, often they'll be talking about, there should be 1 continuous variable, there should be 2 continuous variable, and so on. So here, let me talk about individual observation. For individual observation, arithmetic mean is summation x by n. And for discrete series, you will have frequency. So summation fx by summation f, and summation f is total number of observation n. For continuous observation, which has a class, continuous series means you can say that in that series you have a class of interval 10 to 5, 10 to 20, 20 to 30. Likewise, you have a class of interval. For those, find the mid value first. Find the mid value first, multiply with the frequency, then multiply by n. So for arithmetic mean, we'll be discussing about three types of observation or three series. One is individual, one is discrete series where you have the frequency, one is continuous series where you have a class of interval. So there are so many methods like step deviation method, assuming method. I'm not discussing that. If you know one method, then the rest can be calculated. Now you need not to calculate this, but in the SPSS, but you should know the purpose of that and how it was being calculated. You should know, at least you should know it. During our time, up to MSc, I only know arithmetic mean. In our days, median mode, these statistics parts were never being introduced in the course. Arithmetic mean was there. Right? Nowadays, you find that mean median modes are being introduced from class 9 onwards. But in our time, we know how to calculate arithmetic mean, but since mathematics was there, but no statistical portion was not there. So I never come across like, Z test, X test, and Z test, T test, chi-square during my whole life up till MSc mathematics. I never come across. Even how to calculate, I don't know how to calculate even median in those days. Or was pure mathematics and nothing about statistics was being discussed. Later on, we realized that statistics is a paper which is very much important in all streams of, in all disciplines of academic education. Now let's go to individual observation. So only 2 hours. So let me, so many things to be covered. Let me take the pace. So for individual observation, now from the following data of revenue obtained by 6 salesmen, calculate the arithmetic mean. See, this individual observation 20, 30, 40, 50, 60. So you add them all and divide by the total number 1, 2, 3, 4, 5, 6. So you add them all, summation, add them all to 70, and then divided by n6. Those who are not having the mathematical background or statistical background, understanding the research, research analysis up to the stage of hypothetical testing will be very much, difficult for them. For them, they should make a tabulation. Then at least they should know how to calculate arithmetic mean, median mode, and percentage. But for making further analysis, without the knowledge of mathematics, without the knowledge of statistics, you can't go further. Divjyoti? Divjyoti? Hello, Divjyoti?
Yes,
Divjyoti? No, there should be someone because it is showing internet is not stable. So when may I know your name, please?
Sir, Vicky Sharma.
Preeti.
Vicky Sharma, sir.
Vicky. So when I have some problem, so you should be there.
So, sir,
I always ask. I would often ask, is it visible or audible? Sometimes it is showing that your internet is unstable. My internet is unstable. That's why.
So you can just do one thing, sir. If it is possible, you can share your slides with D2T, sir. And on behalf of you, I will share your screen and you just give in your deliberation, sir.
No, that will be difficult because I have to move here and there. I have to move up and down. Whether it is visible or not.
So it's visible, sir. It's visible.
Okay, because I have to move up and down often.
Okay, sir. Okay.
So for individual observation, this is the example. You have individual observation, make a summation, then divided by the total. Now for the discrete series, you have number of frequency here. For this 28 times, 30 12 times, 40 20 times, 50 10 times. So for these, you have frequency multiply with this variable value. This value of the variable multiply with the frequency, make the summation, and then divided by the total number of observation or summation f. So here summation f is the total number n, 60. So f into x you multiply f into x 160, 12 into 130, 360. So when you do the fx, then summation of this will be 2460. So here fx divided by n. So this is the arithmetic mean. But in the case of class interval, this is continuous series 0 to 10, 10 to 20. First you find the middle value of this. First you find the middle value of this and multiply the middle value with the frequency. Now here marks middle value is 0 to 10, 5. Marks 10 to 20, mid value is 15. So you multiply this mid value with the frequency 25, this mid value with the frequency 1. So and ultimately you make a summation FM. This is a total number of observation, and you get here mean is FM by M. So 33. So arithmetic mean can be calculated. Arithmetic mean can be calculated for individual observation, for discrete series where you have a frequency, for continuous series where you have a class of interval, you can easily calculate the arithmetic mean. Now, for median. Now, what is median? Median. What is median? Median is the value in the series, which divide the entire series into two parts. One part comprising all the values greater than that value, and other all the values less than that value. That value is called median. You have a series of data. In that series, median is that value which divide entire less than the median, and then another part having the value more than the median. And median is also called positional average. Positional average. Median is also called positional average. Now, for calculation, first individual observation, discrete series, continuous series. In the case of individual observation, when n is an odd number, when total number of observation is odd, when total number of observation is even number, how will you calculate that? For discrete series, how will you calculate that? For continuous series, how will you calculate that? Now, when n is odd, median is the size of n plus 1 by 2. We call it n plus 1 nth item. Size of n plus 1 nth item is for odd value. For the even number, size of n by 2 item plus size of n by 2 plus 1 item divided by 2. Whole divided by 2 is the median size. Now, for individual observation, it can be for odd or it can be for even. Then for discrete series, simply this is the formula. And for a continuous series, first you have to find the model class, median class. After finding the median class, find the lower limit. Then you have to find the F, C, and I. This is I. This is I. L is the lower limit of the median class. N is the number of observation. C is the cumulative frequency of the class preceding the median class. And F is the simple, this is small f. This one is small f. This one is small f. Simple frequency of the median class. And I is the width of the median class. Now we have to calculate the median, and median is that value which divides the entire series into two equal parts. We have to so this is median. So let's go for the first one. The income of 5 employees are, the 5 is odd number, 1, 2, 3, 4, 5. 5 is odd number. Now, since 5 is odd number, the median is size of n plus 1 by 2 item. Your 5, n is 5 plus 1, so third item. See, in the case of median, you know, you have to order the data into ascending order or descending order first. The given data should be arranged according to ascending or descending order first. This data, you see whether it is in ascending order or descending order. Arranging the data in ascending order. No, here, this income, 900, 1020, these are the incomes of 5 employees. In the case of median, arrange them according to ascending or descending order. Now we have arranged according to ascending order, 900, 950, 102. So in the ascending order. Now, after arranging that, size of n plus 1 item, size of 5 plus 1 by 2 item, so size of third item. Now 1, 2, 3. So this is the size of third item. So this is the size of third item. So this is the median. For individual observation, so again, the definition says that median is that value which divides the series into two parts, and one part having the value less than the median. 900 is less than 1020. 950 is less than 1020. And the other part 1200 is greater than 1020. 120 is greater than 1020. So median is that value which divides the series into two equal parts. Okay, so one part having the value less than the median, another part having the value greater than median. So then when it's odd or even number, the income of 6 employees are this. Fine. See, this six is even number. Find the median income. Now arrange the data into first according ascending order or descending order. First, let's according ascending order. 900, 950 ascending order. After this is even number. This is even number, so you have to apply the formula. For even number, this is the formula. For even number, this is the formula. Size of n by 2 item by n by 2 plus item by 2. So n by 2 is 6, third item, fourth item. So size of third item, size of fourth item, then divided by 2. Now you go through the data. Size of third item, this one. Size of fourth item, this one. Now in the formula, the size of third item is 1020. In the formula, size of fourth item is 1200. So you put here, then divide it. So this is the median. So this median falls somewhere in between these two. Somewhere, since this is even number, median falls somewhere in between these two, and this divides the set into two equal parts. Now coming to the for the discrete series. In the case of discrete series, you have whole number. These variables are whole number, and you have frequency. From the following data, find the value of the median. And then you have a frequency. When these values are in the class, say 1000 to 1500, 1500 to 1900. Now, in the case of discrete series, you have the first, after arranging the data, again, this kind of unstable. Divo.
Sir, tell, sir.
Vicky. Visible.
Visible, sir, visible.
Audible, visible.
Audible and visible too, sir. Visible, sir.
Vicky. Audible.
Yes, sir.
Sometimes the signal is coming that your internet signal is unstable. Okay?
Yes, sir. I think you have some little bit problem in your internet.
Now first do the ascending order, then find the cumulative frequency. Okay, time is killing. So see, these are basic things, limiting mean, median, mode. So you can easily calculate it. Let's go to something that something related to research. First of all, we should know how to calculate limiting mean, median, mode. After that, we should go further. So how to calculate these things? Limiting mean, median, mode are basic things. So if time permit, I'll come back again. But let's go to something else that we need to do after calculating a limiting mean, median, mode. So so my dear friends, I'll be coming back to again how to calculate limiting mean, median, mode. I've done up to median. Up to more, I'll come back again. See, after knowing, these are basic things that we have learned in the lower classes. Nowadays, we have learned in the lower classes. So after knowing limiting mean, median, mode, another one descriptive statistics which is very much important is dispersion. So you may be having you may be having, equal average, but how the items within the series varies plays very important role. Now, for example, you have series A, series B, series C. These are the series. Here, arithmetic mean is 100. Now, for series B also arithmetic mean is 100. For series C also arithmetic mean is 100. But how the items varies in between is different. But how the item varies in between is different. Now here is 100. The arithmetic mean 100 is representative of all these 100. But again, this 100 is also representative of all this. But here some variation is there. But here there is much variation is here. This 100 arithmetic mean represents this, but inside there is much variation. So whether inside whether even if we have the arithmetic means equal, whether how do the item varies in between, we have to find out. So you see the arithmetic means are the same, but items inside varies differently. So how the item varies inside a series, you can easily calculate by knowing by calculating the dispersion. So here lies the importance of dispersion. The various measures of central value discussed give us one single figure that represents entire data, but the average alone cannot adequately describe a set of observations unless all the observations are the same. So it is necessary to describe the variability or dispersion of the observation. So average alone, you should remember, average alone cannot adequately describe a set of observations unless all the observations are same. Now, a person may be getting 80%, another person may be also getting 80%, but for the first person, for all the papers he get near 80, 79, 80, 81, 81. But for another person he get 33 also, he get 40 also, he get nearly 90 also. So there is much variation, much variation. So even though arithmetic mean is same, how far the value varies inside the series, you can easily calculate by knowing the dispersion. So here lies the importance of studying the dispersion. So method of studying variation, here range is there, interquartile range is there, and the average standard average deviation or mean deviation. This one standard deviation. This is called standard deviation or mean deviation. Sorry. Range, interquartile range, and then average deviation or mean deviation and standard deviation. So we'll be discussing only here standard deviation because in research you have to mention in the descriptive statistics mean you have to mention, standard deviation you have to mention, and then sample size you have to mention. So you should know how to calculate standard deviation because before we proceed to further to statistical analysis, you have to mention in the table all the descriptive statistics. So regarding the standard deviation, two things are there. One is absolute measure and another is relative measure. Absolute measure of dispersion are expressed in the same unit in which the original data are given. There is rupees or kilogram. But whereas relative measures do not express in terms of unit. So it is expressed in terms of percentage. So for comparison purpose, you can easily compare by relative dispersion. Between, when you want to compare between the two series whose units are different, then you have to use measure of relative dispersion for comparison. And how to calculate it? Absolute measure of dispersion divided by appropriate average and then divided by multiplied by 100. So I will show this in the calculation. So if there is two series, one series is 50% coefficient of variation, another is 10% coefficient of variance. Coefficient of variance means relative dispersion, measure of relative measure. This measure of relative dispersion is also called coefficient of dispersion, CV. One series has a variation of 50%, another series has a variation of 20%. Then we can go to the conclusion that the series having the 20% variation is more uniform than the another series having 50% coefficient of variation. So from these, you can easily do the conclusion that which series is more uniform than another series. Now, standard deviation. So the standard deviation concept was introduced by Carl Pearson in 23. And the standard deviation series, this standard deviation is denoted by the small Greek letter sigma. So standard deviation is denoted by Greek letter sigma. And standard deviation measured the absolute dispersion of the distribution. Now, thus, if we have two or more comparable series with identical or near identical means, it is the distribution with the smallest standard deviation that has the most representative mean. Two series may be having the same arithmetic mean, but that arithmetic mean will be more representative of that series having the smaller standard deviation. So hence the standard deviation is extremely useful in judging the representativeness of the mean, whether my arithmetic mean is representative of the entire series or not. In judging that, the standard deviation will help you. Now again here, for calculation of standard deviation, for individual observation, summation, this small x is large x minus mean of this way. This is large x. This is mean of the large x. So small x is the deviation of the variable of the small x is the deviation of the variable of x from its mean. So this is small x square. So for discrete series, there will be frequency. So root over summation fx square by n. For continuous series, you have to first find the mid value. D is the deviation from the D is the deviation of the variable from its mid value. D is the deviation of the mean of the mean, deviation of the mean of the series from its middle value. So this is for continuous series. First, you have to find the deviation mid value minus mean of the series. Then you have to find the standard deviation like this. This is the formula. The three things. In a survey, it is found that the production of rice in quintal is this. Calculate the standard deviation. This is the figure of the 10 farms. So production in quintal. This is for 10 farms. And after you calculate the arithmetic mean 57, deviation of the value 50 from arithmetic mean, so minus 7. Deviation of the value of the variable from the arithmetic mean 57 is minus 4. So likewise, you have to find deviation here. Then this deviation is represented by small x. So small x square is 276. Then you can easily put in the formula. The standard deviation is root over summation x. This square should be here. Standard deviation is square root summation x square by n. So finally you got a standard deviation of 5.253. And the coefficient of variation is standard deviation by mean into 100. So this gives you 9.21 variation. So for another series, if the coefficient of variation is 20%, then you can say that this series having coefficient of variation 9.21 is more uniform than that series having the coefficient of variation of 20%. So coefficient of variation, either you can compare from the standard deviation or either you can compare from the coefficient of variation which series is more uniform or which series is more compact. Now for continuous series, you are having class 90 to 120, 120 to 150, 150 to 180. So this is the class, this is the frequency. Now how we calculate is that first you calculate the mid value is 90 to 120, what is the mid value? 105. 120 to 150, what is the mid value? 135. After finding the mid value, frequency with the mid value, this will help you in the calculation of arithmetic mean. Arithmetic mean is frequency with the mid value. This is arithmetic mean. Then after finding the arithmetic mean, mid value, deviation of the mid value from each arithmetic mean. So D is deviation of the mid value from its arithmetic mean. So after this D, you can calculate FD square. Then after this FD square, once you know the formula, you can make a table easily. Then you have to calculate, you have to put all these values in the formula. Now, standard deviation is summation FD square by n and so on. After putting this, standard deviation become 58.9, and coefficient of variation by applying the formula 26.2. So ITM, the percentage of ITM vary from each other is from its mid value, from its arithmetic mean. How the ITM vary from its arithmetic mean is 26.2%. So in this way, for standard deviation also you should know how to calculate manually. Nowadays you will not be doing manually, but in those days what we have done was manually like this. The standard deviation we have calculated for individual. If it is individual observation, this formula. If this is discrete series, then this formula. And for continuous series, then this is standard deviation. Now after this, I would like to discuss correlation analysis. The third part, correlation analysis. Now in our life, we always find that one variable is associated with another variable. In the business houses, always we try to find out whether advertising is related with the sales revenue or not. If there is any relationship between advertising and the sales of the company's product, then company will give emphasis on increasing the expenditure on advertisement. So I'll come to the significant part later on. If you are going to apply the correlation like study habit and performance, correlation like correlation like between study habit and performance of the student, or if you want to find any correlation between two variables like advertising and sales, then after finding the correlation R, don't stop there. You have to go another step to test for the significance. In those days, how we do the testing of the significance, I will be telling you. So correlation analysis deals with association between two or more variables. Correlation analysis attempts to determine the degree of relationship between the variables. Now, after correlation analysis, we find correlation R, which not only give us the direction but also the degree of relationship. Now, the problem of analyzing the relation between different series should be broken down into three stages. Determine whether the relation exists, and if it does, measuring it. Test whether this relationship is significant or not. If it is significant, establish the cause and effect relationship. Now, if advertising and sales revenue of a particular product is R is found to be 0.6, then let us test this R whether it is significant or not. If it is significant, then you can establish the cause and effect relationship. No, the more expenditure on advertising, the more will be the sales revenue. So before drawing the conclusion, whatever the value of the correlation R you get, first you have to go for testing. Clear? So there are different types of correlation. Positive correlation, negative correlation is there. Positive correlation, negative correlation. If both the variables are varying in the same direction, then positive. If one goes upward and one goes downward, then negative. Now, if advertising 10, 12, 15, 18 increasing, sales 15 to increasing, then it's called positive correlation. Now, if advertising 20, 30, 40 increasing, but sales decreasing 40, 30, 20, 10, then it is called negative correlation. So types of correlation can be positive or negative. And the correlation can be simple, partial, or multiple. Simple, partial, or correlation can be positive or negative. Correlation can be simple, partial, and multiple. When only two variables are studied, it is a problem of simple correlation. I'm talking about advertising and sales only. So it is an example of simple correlation. When three or more variables are studied, it is a problem of either multiple or partial correlation. Now, in multiple correlation, three or more variables are studied simultaneously. When we study the correlation between yield of rice per acre of land and the amount of rainfall and the amount of fertilizer used, it is a problem of multiple correlation. Now, yield of a rice, yield of a crop depends upon the fertility of the land, depends upon the amount of rainfall, depends upon the type of manure you are using. So when you are studying all these things simultaneously, then it is a multiple correlation. But in partial correlation, we recognize more than two variables, but consider only two variables to influence each other. The effect of other variables influencing the variable being constant. Even though multiple variables are involved, here But you assume that other variables are being remaining constant, and you consider only two variables at a time, keeping other variable constant. Then it's called partial correlation. Now, if the correlation analysis is only of two, then simple. If it's more than two, then it's multiple or partial. In the case of partial, even though multiple variables are influencing each other, only two variables are being taken at a time by considering the other as a constant. So simple, partial, and simple, partial, multiple uh, correlation is also there. And then linear, nonlinear is there. The linear, nonlinear correlation is also there. When you draw a graph, if you get a straight line, then it is called linear correlation. And when you plot those points and when you draw a line and it is on all the points doesn't fall on a line, doesn't fall on a line, then it is called non-curvilinear. Or you can easily find out 10 to 20 difference is 10, 70 to 140 the difference is 70. So 10 by 70, how much? 1 by 7. Now 20 to 30 difference is 10. 140 to 110 difference is 140 to 110 to 110 140 difference is 70. So when you divide the change in this by the change in this y, and when you divide the change in this by y, there is a constancy. Then we call it linear correlation. Clear? Change in x divided by change in y. Again, change in x here and change in y here divide. And if the ratio is equal, then this is called linear correlation. Now, why do you study correlation? Significance of studying correlation. Most of the variables show some kind of relationship. There is relationship between the price and the supply. There is relationship between income and expenditure. With the help of correlation analysis, we can measure in one figure the degree of relationship existing between the variable. Our income and our expenditure are related. Then we can easily find out we can easily find out with one figure the degree of relationship existing between the variable. Once we know that two variables are closely related, we can estimate the value of one variable given the value of another. This is known with the help of regression analysis. Once you know that there is a correlation exists, then you can go further for regression analysis. Then with the help of regression analysis, you can easily calculate the value of one variable with the help of another variable. So in business, correlation analysis enables the executive to estimate cost, sale, price, and variables on the basis of some other series with which this cost, sale, price may be functionally related. The effect of correlation is to reduce the range of uncertainty. The prediction based on correlation analysis is likely to be more near to reality. Now, method of studying correlation. Scatter diagram method is there, graphing method is there. Here, these two could not give you the degree of relationship. Simply, they can give you the direction of relationship by plotting by plotting a scatter diagram, and then you can come to a conclusion that whether it is positive, negative, or whether it is related or not related. But it doesn't give you the degree of relationship. But Culp-Pearson coefficient of correlation and Spearman's rank correlation coefficient give you the degree and the direction of relationship. Current division also, but concurrent division is not widely used. But in S-spaces, we will be talking later about the Culp-Pearson coefficient of correlation and Spearman's rank correlation coefficient. So not only you have to find the value of R, you have to go for testing whether R is significant or not. That I will show you. Now, Culp-Pearson coefficient correlation, how you derive? So R is given by xy divided by n summation x summation y. How it is being derived, we will not be discussing here. So R is summation xy and standard deviation x standard y. This x is division of the variable from its mean. This y is also, this is small y, division of y variable from its mean. N is the number of pair observation, and the standard deviation of x series. This is the first formula, but when you modify this formula in the next stage, See, I'll show you now. Right now, the value of R is from +1 to -1. R0 is no correlation. The formula is used only when the deviation is taken from the actual mean and not from the assumed mean. Okay. Now, uh, the value of R is from +1 to -1. In practice, getting +1, 0, and -1 are rare, but the value of R is from +1 to -1. Now, if you modify the earlier formula, you know the formula of standard deviation. Standard deviation is summation deviation of the variable from mean by n. The formula that you know how to calculate standard deviation earlier, you multiply, you apply here. Then ultimately you can modify this equation. This equation after substituting the value of standard deviation of x, standard deviation of y. Finally, you got this formula. There is summation xy root over summation x square summation y square, and this formula is for direct formula. This is we often use this one, but no number 3. This formula is also a formula of finding correlation R by direct method. Directly, you have to put the value x. You find out xy, then you find the summation x, then directly you substitute here, then you will get a value of R. Now remember one thing, as I have said, remember one thing, between two variables, for example, advertising and sales, the performance of the student and the study habit. So first you find the correlation R, then test its significant. Whether R is significant or not, don't R may be 0.5, 0.6, 0.7. Don't directly come to the conclusion whether R is significant. But in SPSS analysis, simply by looking at the p-value, you can draw the conclusion that R is significant or not. But here, in manual calculation, how we did that, I'm showing you. Establish the cause and effect. After that, if significant exists, then establish the cause and effect relationship. Now look at this formula. Calculate the Culp-Pearson's coefficient of correlation from the following data. This is whether there is any relationship between the marks obtained by the student in accountancy and the marks obtained in statistics. We say that those who are good in statistics will also be good in accounting. But let us see, those who are good in statistics has something to do with the marks secured in accountancy. Now, row number decide. Okay, accountancy mark here, statistics y here. Now, if you look at the formula, of correlation R, you have to find xy. You have to find xy, then you have to find x squared, summation x squared, you have to find y. By looking at the formula, you prepare a table. The x is here, y here. So this small x is deviation of the variable from its mean. Y, deviation of the y variable from its mean. Then x squared is this one. This is small x. Small x squared, small y squared, and small x, small y. Multiplication. This small x is value of the variable, deviation of the value of the variable from its mean. This small y is deviation of the variable y from its mean. And this is small x squared, small y squared. So by looking at the formula, as per your requirement, you make a table. Then after that, you substitute. After that, you substitute here and you get the value of R. R is equal to 0.429. But by looking at this 0.429, you can't say that R is significant or not. So in the correlation analysis, first you have to find correlation R, then go for testing. In SPSS, simply by looking at the p-value, if the p-value is less than 0.05, then you can come to the conclusion that R is significant. But here, what to do? Now you have to go for probable error. In SPS, in the statistics books written by S.P. Gupta, it is said that probable error is this 0.6745 1 minus r square by root over n. Now, if find PE is this probable error and 6 PE is this, and if the R is greater than 6 PE, If R is greater than 6, if R value calculated here, we have calculated 0.429. If 0.429 is greater than 6 times PE, then R is significant. Now here 6 times PE is 1.44. 1.44. Your R value is 0.429. R value is 0.429. R value is 0.429. And 0.429 is less than 6 times the PE, 1.44. So R is not significant. R is not significant. So whether the value R you have calculated is significant or not, you have to refer to PE, probable error. So probable error formula is this. And if R, the calculated, is greater than the 6 times of PE, then R is said to be significant. Or you can go for t-testing. T equal to R root over n minus 2 by 1 minus R square. Let me repeat once again. If you don't want to use probable error, whether the R that you have calculated, whether R you have calculated is significant or not, then you have to apply t-testing. T equal to R root over n minus 2 by 1 minus R square. So normally we check whether R is significant or not with this probable error or t-testing. No, or another is find the R square. R square is this is R square, so 18%. So right now this R value was 0.429. Now you do the squaring of this and you got 18%. So out of the 100, only 18 out of 100, only 18 of the variation was explained. So R is not going to be significant one. Out of total variance of 100, if you do the R square later on, 18 by 100 is coming. So out of 100, only 18% was explained. So if it had been 50% or more than 50%, then you can claim that R is significant. Since out of 100, only 18 was explained by this statistical tool, so you can't come to the conclusion that R is significant. So whether R calculated here equal to 0.429 is significant or not, you can do it by, you can check it by probable error or coefficient of determination. R square is called coefficient of determination. Or with the help of R square, you can say that R is significant or not. Now, if you are collecting the data on ordinal scale, or if the data are in the form of rank, then you can't use Culperson's correlation coefficient, R. You have to use Spearman's rank correlation coefficient. Now, Spearman's rank correlation coefficient is when quantitative measurement cannot be made. When quantitative measurement cannot be made, that is for efficiency, you can say efficiency in terms of ranking. Mr. XY, which one is having more efficiency? Mr. X is having more efficiency than you can't say his efficiency is 20%. You can accurately say regarding the honesty also. You can rank who is more honesty among these people. But you can't say that exactly the honesty of this person is 20, honesty of this person is 50. You can't say exactly. Where you cannot say exactly, but you can say in terms of ranks, then Spearman's rank correlation coefficient can be used. So R is 1 minus here 6 summation D square and N square max. This is a formula. D is the difference in ranks between two variables. And N is the number of pair of observation. So when the data are given in rank, you can use this one. Or even when the data are not being given rank, if you can do the ranking, then you can use this formula. But normally, Spearman rank correlation coefficient is used when you are collecting data on nominal or ordinal scale, and particularly for qualitative data. So let's see whether these are the ranking of 10 students. If some data are being given in terms of ranks, then you can do easily. But if ranks are not there, you can do the ranking on your own. You can do the ranking after arranging the data. After looking at the data, you can do the ranking. Which one is the rank 1, rank 2, rank 3? The ranking of 10 students in 2 subjects in accounting and auditing are given below. This one. Vicky, is it audible still? Any problem, Vicky?
Are audible, very clear.
Very clear, sir. Very clear.
So I was worried. For some time here it was showing your internet was unstable.
So
Not
earlier
issue,
it
sir.
was having some problems. Now it's all right.
So now, if the datas are given, if the datas are of qualitative nature, like honesty, or if the datas are given in terms of rank, then you have to apply this Spearman's rank correlation coefficient. What you have to do is the ranking of 10 students in two subjects, accounting and auditing. We want to see whether the ranking of accounting a student has is related with the account with the his rank in auditing, or whether his capability in accounting is something to do with the capability in auditing or not. You can easily check it out. So first one, rank R1, R2, difference in rank. So 6 minus 3 is 3, so 3 square is 9. 4 minus, you see, R2 minus R1. 4 minus 5 is 1. D square is 1. 9 minus 8 is 1. The difference, 9 minus 1, 9 minus 8 is difference is 1. So D square, so R1 minus R2 whole square. So D square is difference in rank, then you do the squaring. D square is, first you take the difference in the ranking, then you do the squaring. So summation D square is here 214. Now you apply the formula. Calpers, the symbol R is used. Symbol small r is used for Calperson correlation coefficient, but a symbol large capital R is used for Calperson's correlation coefficient as a Calperson correlation coefficient. Formula is 1 minus 6d square n, and this is the formula. You substitute here summation d square, that's 214. Then multiply by 6, then you simplify it. Now minus 0.2962. So in the case of Calperson correlation coefficient, you either you do, I said you refer to probability error, this one. I told you to check with the probable error. In the case of Calperson correlation coefficient R, whether it is significant or not, you refer to probable error or t-testing. T is equal to R root over n minus 2 by 1 minus R square. But here I have shown you with a probable error. But what about the this one? What about the Calperson, this one, Spearman's rank correlation coefficient? You can apply the same thing what was applied for the probable error. It was clearly written that for Calperson's correlation coefficient R, either you have to refer to the probable error or the t-testing or coefficient of determination for interpreting whether R is significant or not. But in the case of Spearman's rank correlation coefficient, what to do? Now you have to refer to the table. You have to refer. See, this minus sign is just either you can take absolute value or minus sign is just, if you look at the normal distribution, left side, right side is there. The value which are on left side we put in negative. The value on the right side we take it as a positive. Now either you can take absolute value or you can draw the normal distribution and you can draw the conclusion. Now your interpretation of the value R, there is no correlation in the rank data of the population. This is rho is for the capital R is for the sample. Now this rho is for a population. There is no correlation in the rank data of the population. There is a correlation in the rank data of the population. You take alpha is equal to 0.05. Now you look at the table here. For Spearman's rank correlation coefficient, you have to refer to the table. So for 5%, 0.05. Now here, 0.6364. 0.63 for Calperson here. Value of Spearman's rank correlation, whether the value R that you get by using the formula of Calperson, Spearman's rank correlation coefficient is significant or not. You have to refer to the table. Now here table for alpha square 5% is given here 0.6364. Look at this, 0.6364. So 0.6364. The right side positive 0.63 634 right type negative. Now the value that you got was, now the value that you got here is minus 0.2962, 0.2962 minus 0.2962 will maybe somewhere here within this white portion. This is minus 0.632. So minus 0.2 will be somewhere here in this white portion, and this is zone of acceptance. This is zone of acceptance, and this red portion is zone of rejection. Your 5% you divide into 5% you divide by 2, so 0.025. Since it is two tail case, 0.025 area is here, 0.025 area is here. But as far as value is concerned, 0.63 positive, 0.6364 is here, negative minus 0.636 here. Your 0.2, this value, uh, this value 0.29, your 0.29 must be here. So in the zone of acceptance. So your null hypothesis is accepted. Your null hypothesis is the table value is 0.6364 at alpha of 7 and M10. Since R value, the calculated 0.29 is less than 0.354, null hypothesis is accepted. There is, your value R is not different from 0, or there is no correlation. This minus 0.296, or if you forget the sign, 0.296 is not significant. Is not significant. Even though it has a value of 0.296, this R is not significant. This R is not significant because the table value is 6364, and the calculated value here is 0.2962. 0.2962 is less than 0.2962 is less than 0.6354. So null hypothesis is accepted. Null hypothesis is accepted. There is no correlation. But regarding the language, accepted, not accepted, some senior research statistician says that don't say accepted, you say not rejected. Here null hypothesis accepted. See, we have been using accepted, not accepted, but some senior member in the statistics field, they said that don't say accepted, don't say that it is not rejected. Why? Because we are studying the sample, not the whole population. The conclusion drawn on the basis of the sample study, there you can't say accepted. Instead of say that, the better word will be not rejected. This is the comment given by some of the senior teachers. Now, this formula of Spearman's rank correlation can be modified when you have equal ranks. Sometimes it also happens that some of the data are having equal ranks. Some in data, sometimes you may have equal ranks. So what happens is that here in this accounting, so 3, so sometimes 3, 5. Sometimes a person may be having here the third rank, another person may also be third rank. So in those cases, again in auditing, another 3% may be having, in auditing case, 3% may be having the same rank. They may be having the same rank. Then in accounting, they may be having the same, 2% may be having the same rank. In that case, you have to multiply these. You have to modify the formula like this. If you have one case of equal rank, then you have to add only this portion, m cube minus m by 12, only one. If you have two cases of equal rank, then you have to add m cube minus m, another this factor, m cube minus m by 12. One case of equal rank, one factor of m cube minus m by 12 will be added. If you have two cases of equal rank, m cube minus m with these two factors will be added. Suppose we have two cases of equal rank. Now, how many persons m? In the first equal rank, 3 persons are having equal rank, then m value will be 3. In the second case, only 2 persons are having equal rank, then here m value will be 2. So nowadays you will not be calculating manually there, but you should know that when there is equal rank, then formula has to be modified. For every case of equal rank, the factor m cube minus m by 12 is added. If there are 2 cases, then 2 factor will be added. If there are 3 cases, then this type of 3 will be added. But regarding the value of m, In first case, 3 persons have equal rank, the M value will be 3. In the second case, 4 people have equal rank, then M value will be 4. So this is a modified. And now let me draw conclusion here again. In the case of correlation, see, often in our life, one variable is always related with another variable. The performance of the students also related with the study habits. The anxiety of the person also related with another variables. So what happens is that always will find one variable related with another variable. Advertising related with the sales revenue. So correlation has to be calculated. Now after calculating the correlation R, you have to test whether the value of R is significant or not. If the value of R is not significant, then you cannot establish cause and effect relationship. If R is significant, then only you can establish the cause and effect relationship. The more the advertising, the more the sales. So you can establish the cause. The more the rainfall, the more is the yield of the crop. Okay, like this. The more the attendance of the student, the more the performance, the more the commitment of the employees, the more is the productivity. So once R is found, then you have to go for significant testing. In the case of correlation R of, if you calculate it by Persian, then go for probable error or t testing. Otherwise, in the case of Spearman's rank correlation coefficient, you go for table. So this is all about the theoretical value. Now, case of significance. Case of significance. Case of significance. Now, suppose in a sample, 100% and 100% like the product. In a sample of 100%, 60 like the product and 40 do not like the product. In a sample of 100, 60 like the product and 40 do not like the product. Difference is 10. Whether this difference is significant or not, or is it by chance? Significant means whether it is important to take into consideration in our decision making, or it so happened by chance, ignore it. Now, whether this difference is happened by chance or in reality, it happens because more number of people like the product, 60 like the product and 40 do not like the product. Whether this difference of 10 is by chance or in reality, more number of people like the product or not, you have to check it. Checking this is called case of significance. Or if this difference of 10 is significant, then the difference is this difference of 10 is include by chance also and also true difference. But if this difference is by chance only, then there is no true difference. This difference happens to be by chance only. Otherwise, those who like the product and those who do not like the product are almost equal. So this do the observed difference. Do the observed difference of 10 represent the true difference found in the real world, or could have occurred by chance because of the variation, possible when a sample is used. Since we have used a sample by chance because of the sampling fluctuation, or does it happen, or in reality it happened because it is there? Now, it is highly unlikely that the observed difference could have occurred by chance. There is by chance, say by chance of 5 out of 100. May decide that the difference are significant. The difference are significant different. We may decide that the difference are significant different. If this difference is by chance, then we can consider that this difference is significant. But if it is not by chance, then the difference observed in the research data represent the true difference that exists within the total population of interest. Then we can say that the difference is significant. In short, we collected data from the sample. We found that mean income of say mean income of Impal is mean income of Karimganj. Mean income of Karimganj is 60 and the mean income of Silchar is 40. So difference is 10. So the difference is suppose 20. Sorry. The difference is 20. Difference is 20. Whether this 20 is by chance or in reality, there is a difference that Silchar are more well-to-do than Karimganj. Suppose Silchar's mean income of the household is 60. 40 is the mean household income of Karimganj. Now difference is found to be 20. Whether this 20 difference is by chance because we have studied a sample, or in reality, the mean income of Silchar are more than the mean income of Karimganj because Silchar peoples are more well-to-do. So we want to check that. We want to check that. While checking, this difference of 20 come out to be by chance. Then we'll come to the conclusion that there is no difference in the mean income of Silchar and Karimganj. There is no difference, they almost equal. But if this 20 happen to be a true difference, and in the true difference, you'll find chance plus, in this total variation of 20, you'll find chance plus true variation. Then you may come to the conclusion that this difference is not only by chance, but there is also true difference. Meaning thereby, the difference is significant. So the mean income of Silchar is more than the mean income of Karimganj. So test of significance is we are just testing whether the relationship is important enough to draw the conclusion or not, whether the difference is important enough to draw the conclusion or not, whether the difference or the relationship is by chance, then you ignore it. But if it is not by chance, it includes true difference, then it is significant. Then you have to incorporate in your decision making. Yeah. So this is all about case of significance. Whether the difference, whether the relationship is, see, anxiety, stress. So mean stress of women teachers is means 20, and mean stress of male employees is male teachers is 25. Mean stress of male teachers is 25. Mean stress of women teachers is 20. So difference is 5. Whether this difference of 5 in the stress measurement is significant or not. If it is significant, then male teachers have more stress than the women teachers. But if this difference of 5 is insignificant by chance, then you will come to the conclusion that stress of the teachers among the male teachers and female teachers are almost equal. Almost equal. So we are checking whether it is by chance or in reality there is a difference or not. Now, before we go for testing the hypothesis, you should know some terminologies. Before we go on testing the hypothesis, some terminology you should know it. Now, in the statistical inference, two things comes up. Statistical inference, two different classes: hypothesis testing and estimation. Now, to test some hypothesis about the parent population from which the sample is drawn. Hypothesis testing means you are making an assumption about the population from which the sample is drawn. Assumption. See, long time back we have studied, some around 500 households of Manipur, and we come to the conclusion that Manipuri peoples have different brand preference of television, but their preference do not depend on income. Once they like Sony, then they'll buy Sony by borrowing or by taking loan. Their preference do not depend upon income. What they like, they purchase it, do not depend on income. There was those days. So we studied only 500 households and drew the conclusion of entire Barak Valley and entire Manipur Valley, 4th district. So we studied the sample and drawing the conclusion for the entire Manipur or entire valley. So that is called hypothesis testing. With the information that you got from the sample, and then we are testing the assumption about the total larger population. Hypothesis testing is to test some hypothesis about the parent population from the sample. Now, if from the sample mean income of Silchar is say 5,000 per month, or say 5,000 per month mean income of the people is 5,000 per month. Now you can estimate that mean income of the entire Silchar Valley is 5,000. To use the statistics obtained from the sample as estimate of the unknown parameter of the population for entire population, we study only 1,000 households, and if that sample is representative, then we can come to the conclusion about the entire households of Silchar. From the sample of say 500 households, the mean income of households of Silchar region is 5,000 per month. Now if the sample is representative of the population, then we'll come to the conclusion that for entire Silchar population, the mean income of every household is 5,000. So two things: one is testing the hypothesis, and one is whatever the data you collected, whatever the statistics you got for a sample can be assumed to be processed as a characteristics of the entire population. Suppose the standard deviation of the sample is 0.5. Now standard deviation of the sample is 5 rupees. So you can assume that the standard deviation of the entire Silchar is also 5 rupees. The mean income is 5,000 per month. So you can come to the conclusion that mean income of the entire population of Silchar is 5,000. So data that you get, the characteristic or the statistic that you get from the sample, you assume or you estimate it to be the same as that of population. So the one thing that is very important, that is, until unless your sampling is probability sampling, you can't go for hypothesis testing. That I will mention later on. If you want to test hypothesis, then your data should be collected by using the probability sampling. Now, there are four things happening in the possibilities in hypothesis testing. There are 4 possibilities in hypothesis testing. Your hypothesis is true, and you accept it, then correct decision. Your hypothesis is true, and you reject it, then it's called type 1 error. Type 1 error. A good teacher was rejected in a selection procedure. So the teacher was good, but the selection process, by mistake, he was being ignored. There is type 1 error. Hypothesis is false, and you accept it, type 2 error. Hypothesis is false, and you reject it, then correct decision. Now, a person which is not worthy to become a teacher, but because of the procedure it was being selected, then it's called type 2 error. Type 2 error. So a person which was not supposed to be selected was being selected, type 2 error. A person which was not to be selected was rejected, then correct decision. Now, in the case of hypothesis testing, there are 4 possibilities. Your null hypothesis is true, and you accept it, correct decision. Your null hypothesis is true, and you reject it, type 1 error. Null hypothesis is false, and you accept it, type 2 error. And the null hypothesis is false, and you reject it, correct decision. Now, which one is more dangerous? Theoretically, type 2 error is more dangerous. Then if time permit, we'll explain that later on. A criminal is being released. A criminal in the court proceeding, enough evidence were not being there. So a dangerous criminal was being released. Type 2 error. A person being totally honest, innocent, there was being because of lack of evidence, he was being sent to jail. But in fact, he was innocent. Type 1 error. So which one is more dangerous? A criminal leasing to the society or an innocent person confined in jail? Which one is more dangerous? You said a type 2 error is more dangerous. But there are situations when type 2 error is more favorable than the type 1 error that if time permit we'll discuss. Now, alpha is probability of type 1 error. What is type 1 error? Rejecting null hypothesis such that null hypothesis is true. See, type 1 error in alpha is different. Alpha is the probability. Alpha means probability of occurring type 1 error. Alpha is probability of type 1 error. So probability of rejecting null hypothesis when is so if alpha is 5% means what? Out of 100 occasion, 5 times I may be rejecting the true hypothesis. So often we test the hypothesis and alpha is equal to 5% or 20% or 10%. Meaning is that error is out of 100 occasions, I may be making a mistake of rejecting true hypotheses, whereas these hypotheses are true. And beta is probability of type 2 error, means accepting null hypothesis which is false. Beta reflects the probability of accepting accepting null hypothesis, which is false. But we focus on alpha. No, yes, I also mentioned the type 2 error is more dangerous, so don't touch it. Alpha is 5%, 20%, 10% for testing the hypothesis. Often you found that alpha for social sciences is 5%. For physical sciences, they can go up to 1%. At the maximum 5% up to 5% we go in the social sciences. Alpha is probability of rejecting true hypothesis. Okay, there is, if 5% means out of 100 occasions, 5 times I may be making the mistake of rejecting true hypothesis. Level of significance is alpha value. The confidence with which the researcher reject or retain the null hypothesis depends upon a significant level adopted. The significant level is customarily expressed as a percentage such as 5%. It is the probability of rejecting the null hypothesis when it is true. As I have just mentioned, alpha is also called level of significance. A level of significance at which you will be rejecting or accepting your hypothesis while testing it. So probability of rejecting true hypothesis. So level of significance is alpha. Alpha is 5% normally, but in the case of science, you'll find 1% also. Now parameter and statistics. Arithmetic mean, median, mode calculated from the data collected from the population is called parameter. Arithmetic mean, median, mode, size, everything calculated from the sample data are called statistics. Remember this. So often we try to estimate the arithmetic mean, median, mode, standard deviation of the parameter on the basis of the arithmetic mean, median, mode calculated from the sample. So the statistical constant of the population like size, mean, variance are known as parameter, or the value that are derived based on the population are called population parameter. From the entire population, data of the entire population, from that when you calculate arithmetic mean, median, mode, that is called parameter. The value that are derived based on sample are called statistics. From the sample data, you calculate arithmetic mean, median, mode, and these constants are called statistics. So these are the terminology. But parameters are the constraints of the population. Statistics are the constraints of the sample. Test statistics. See, what is test statistics? A test statistic is a number. It may be Z or it may be chi-square, it may be t-test. A test statistic is a number which quantifies and summarizes the observed difference, keeping into consideration of the sample size. For example, Z, when you do the testing of Z, x1, mean x1 minus mean x2, mean of the x1 variable minus mean of the x2 variable divided by standard error. Now, this Z is summarizing the difference. A test statistic is a number which quantifies and summarizes the observed difference, keeping into consideration of the sample size. Now, SC, when you calculate SC, is standard deviation of population by root over n. Standard error equal to standard deviation of population divided by root over n. There n is involved, keeping into consideration of the sample size. In whatever the test statistics, it may be Z or it may be T or it may be F. It is nothing but it is a summarizes, is a numerical value, and it summarizes the observed differences to all together. And while summarizing it, this tool also take care of the sample size, because in the calculation of SC you will be using the n sample size. So a test series is number. It may be chi-square, it may be Z, it may be T, or it may be F, or it may be correlation R. A test statistic is a number which quantifies and summarizes the observed difference, keeping into consideration of sample size. There are two types of test statistics. One is parametric statistics and non-parametric. One is parametric statistics and non-parametric. See, every terminology has a meaning. Parametric statistics, simply you can say that metric data, those statistical tools which are being used for analyzing the data. These data are collected on metric scale. Metric scale is your ratio scale and interval scale are parametric statistics, and if not, then it is non-parametric statistics, or non-parametric statistics is also called population free. It doesn't Non-parametric series doesn't depend on the shape and size of the population. The size of the population is also called population free. Now, parametric series depend on the population parameter, such as mean, median, variance, population size. Parametric statistics depend on population parameters. That means your mean, median, mode calculated from the population. And parametric statistics are Z test, T test, F test. Let me repeat once again. Parametric statistics can be defined like this, or you can say like this. Those test statistics which are applicable on metric data are called parametric statistics, and those test statistics which are applicable on non-metric data are called non-parametric statistics. Or you can say like this: parametric statistics depend on the population parameters such as mean, median, mode, but non-parametric statistics do not depend on the population parameter. Either way, because every terminology has an implied meaning you can define. And non-parametric statistics here are chi-square, Kalmar-Gronow's chi-square is appropriate for nominal data. Kalmar-Gronow's test is D test. This is called Kalmar-Gronow's D test is appropriate for your ordinal scale. Magnamer test is test is appropriate for nominal data which are dependent. So parametric statistics are based on quantitative data. Z test, T test, F test will be depending on quantitative data, which can be actual counts. And non-parametric statistics can be nominal data or ordinal data. Remember, so it depends upon the nature of the data collected. Which technique will be used will depend upon the nature of the data collected. Whether it's collected on nominal scale, ordinal scale, or ratio scale or interval scale. Now, two-tail test and one-tail test. Two-tail test. See, in a normal distribution, a two-tail test of null hypothesis will reject the hypothesis. Will reject the hypothesis if the sample statistic is significantly higher or lower than the hypothesized population parameter. Thus, in two-tail test, the rejection region is located at the in two-tail test, rejection region is located at the two tails of the normal distribution, and this center is the zone of acceptance region. If the calculated value is if the value is significantly higher or significantly lower, then they will be rejected. If the value that you found calculated is significantly higher, like if you calculate the average income of India, average household income of India, if you put Ambani's, Birla's, and then it is going to affect the mean income of the households of India. So extreme items should be neglected, and the beggars who are not earning anything. So these things. So those who are very much small are neglected. Those who are maximally high are neglected. So in between is the zone of acceptance. So presence of extreme items sometimes affects it. So what happens is that here, if it is 5%, then you divide 5% into 2, 0.025. 0.025 here will be the point of rejection. 0.025 here in the left side will be the another resistance. This is called two-tail test. But in the case of one-tail test, depending upon your symbol. So here, remember like this. In the case of two-tail test, your alternative hypothesis will be like this. Alternative hypothesis will be here not equal to. So alternative, in the case of two-tail test, here mu not equal to 100 with the two-tail test. But this is called directional. Here it is non-directional. This is non-directional. So here it is directional. Greater than. If it is greater than 100, then reject it. If it is in the left side, in the case of left side, if it is less than 100, then you have to. So let's talk about one-tail test. In the case of one-tail test, this symbol will not be used. In the case of two-tail test, this symbol not equal to will be there in the alternative hypothesis. But in the case of one-tail test, It is either greater than or less than will be there. If it is in the case of greater than, greater than. So in the case of greater than, all those 5% will be put here. 0.05, 50% will be here, and then out of 100, 50 will be this side, this zone of acceptance this side, and 0.45 will be there, and 5% will be in the 0.05% will be here in the region of rejection. Region of rejection. If the value that you have found is too high, then it will be rejected. This is right tail test, right tail test. But in the case of, and if the value is too low, then in the left side, it is called left tail test. This one is left tail test. So this 0.45, 50 here. So this is mu here less than. So this is less. In the case of less, you will be rejecting the hypothesis on the left side. But in the case of greater than, you'll be rejecting the hypothesis on the right side. So you should remember, when those who are new, totally new, try to understand left tail test, right tail test, or two tail test and one tail test. You should know it. You should know one tail test and two tail test. And in the one tail test, left tail test, right tail symbol. In the case of two tail test, in the alternative hypothesis, no equal to symbol should be used. But in the case of right tail test and left tail test, in the right tail test, greater than symbol will be used in the alternative hypothesis. And in the case of left tail test, you'll be using the less than for the left tail test. So you should know one thing: what is level of significance? Then what is left tail test, two tail test? What is right tail test? What is alpha level? Then you should know degree of freedom also. And then only after that you are ready for testing the hypothesis. But one thing I would like to know, that for testing the hypothesis, there are certain steps to be followed. State null and alternative hypothesis. Select the desired level of significance. Select the appropriate test technique. If a particular test technique, it may be chi-square or it may be z-test, if it will fulfill the condition, then select it. After that, determine the rejection, or this is acceptance zone. This is rejection. This is rejection. So after this, select the rejection region, or determine the rejection region or critical region or decision rule. Then after that, calculate the value of the test, calculate the value of chi-square or z-test or t-test, and then you draw the conclusion about the hypothesis. You can draw the conclusion about the hypothesis. But one thing I would like to let you know, there is, how many hypotheses are there? How many types of hypotheses are there? Long time back, when we were started conducting research work in the 1990s, we come across only two types of hypotheses. There is statistical hypothesis, null hypothesis, and alternative hypothesis. Then suddenly, while going through the research work, one of even my colleague was telling that directional hypothesis, non-directional hypothesis, and so on. So nowadays, people are talking about this type of hypothesis, and you are going to test it. One is research hypothesis. And if the objective is to compare mean score of anxiety of male and female, suppose you are measuring the anxiety during this COVID situation, you want to measure the anxiety of male and female teachers of the schools and colleges. So if this is the objective, your research hypothesis will be there is no significant relationship between the genders and the anxiety of the teachers. If you are making the statement simply like this, there is no significant relationship between the gender and anxiety of teachers, then this type of hypothesis is called research hypothesis. But if you make the statistic like this, there is no significant difference in the mean scores of anxiety of male and female teachers. If you are making the statement like this, no significant difference in the mean score, arithmetic mean, that the measure of central tendency, then this type of statement is called, this type of statement of hypothesis is called statistical hypothesis. Directional hypothesis. Earlier in the statistical hypothesis, we had alternative hypothesis. That alternative hypothesis become the directional hypothesis here. It is said there is significant difference. But when to use this one, when you have a strong belief that you can prove this, that there is significant difference, then only then you can use the directional hypothesis. When you have a sufficient evidence that there is a significant difference, when you strongly believe in that, then you can use the directional hypothesis. And in testing directional hypothesis, it is always one tail test. Remember that in all the directional hypotheses, there cannot be two tail tests. It is always one-tailed test. And in the operational hypothesis, there is no significant difference in the mean score of anxiety of male and female teachers when anxiety is assessed with the help of scale developed by developed by P.K. Gupta or developed by Mr. So and so. In the case of operational hypothesis, the tools that you are using for measuring the anxiety was developed by somebody else, and you are using it. Only then the type of hypothesis will be called operational hypothesis. Clear? Suppose if I'm developing, H.R. Singh is developing a tool for measuring the anxiety of the teachers during the COVID period, and if somebody is using it, then in your hypothesis you have to mention my name because you're using the tools developed by me. And if such is the case, then it's called operational hypothesis. Now, in the next session, we will be testing the hypothesis, how we have done, but real life testing, this time I'm not going to show you because we are not going to use SPSS. In the case of SPSS, simply one click, you will get answer. But theoretically, how we have done that in the past. And how we will be doing in the SPSS will be in the next session that will be introduced. In the last session of this program, how to enter the data, people will introduce it. Now, before I finally call it a day for this particular morning session, the portion that I have left out, let me sum up. First, being a research scholar, first of all, being a person who is conducting research, first of all, what we have to do is, after collecting the data, you have to make a tabulation, then you have to make the categorization. After, in the table itself, you have to find the arithmetic mean, median, mode, whichever is more appropriate. As I already mentioned that if it is nominal data, then it is more. If it is interval scale, then arithmetic mean. If it is Likert or ordinal scale, then median is the most appropriate average. And if it is ratio scale, then geometric mean is more appropriate. So bring the data into order, make a table, summarize it by measure of central tendency, then select the appropriate statistical tools, chi-square. If it is appropriate, select Z-test, select the F-test, and so on. Now, for measuring the measure of central tendency, one of the most important thing of the statistics is that statistics help us in finding one single value, such as arithmetic mean, which represents the mass unorganized data. The way when we say marks, 50%, 60%, it represents all subjects. It doesn't represent one single subject. Now, in that, what you'll be often using is people will arithmetic mean, median mode will often you will come across. You will coming across in the spaces, in the calculation of spaces. Often you'll be using arithmetic mean, but median also there. And then how do we calculate in arithmetic mean? Three cases are there. For a continuous series, where there is a class of interval, or then for discrete series, where there is a frequency of occurrence, for individual observation, where there is no frequency. So you have to calculate for arithmetic mean for this also differently. So there are other methods also, but if you know only one method, it is more than enough. Then after knowing the arithmetic mean, you have to know how to calculate the median. Median is the value which divides the median is the value which divides the entire series into two parts. One part having the value less than the median value, another part having the value more than the median value. Now more or the model value is the value in a series of observation which occur with the greatest frequency. As I told you, that the person who is going back to his village, he should have calculated the more. He should calculate the maximum depth. Instead, he calculates the average height of the average depth of the river and try to cross it because his height is 6 and he get drowned as he enter into the river. There, he should have calculated more. More means the value which occurs with the greatest frequency. The more of the series 3, 5, 8, 5, 4, 5, 9, 3 is maximum occurrences about which the items are most closely concentrated. This definition plays a very important role. So in case here, 54 occur only once, 58 occur only 5, 60 occur only 4, 70 occurs 6, and IT occurs 6. So here it been like this. Here 4, 5, 4, 6 are very much close. Here it been this one 2, here it been this So 58 is the maximum occurrence. So 58 is the mode. But when again what happens is that when you have two maximum values, there are many situations which means a median. So for example, when you have when there are two or more values having the same maximum frequency, then what will you do? You can't do it by maximum by inspection method. When there are two or more values having the same maximum frequency, one cannot say which is the model value. At that time, it is called bimodal. And you have to use only the empirical formula by calculation. More equal 3 median 2 median. These will be used only in case when there is a bimodal situation of bimodal. Situation of bimodal. Now I'll show you. Here it is here. 120 is occurring 3 times. 130 is occurring 3 times. So this is my bimodal case. So you can't say 120 is a more, 130 is more because 3 are there. So in such situation, what you have to do is you have to first find the median, find the mean, then use the formula more is equal to 3 median minus 2 mean. So otherwise, the maximum, otherwise. Hello? Hello? Otherwise, you have to use by inspection method. But in the case bimodal, this one. Now again, when your maximum and the preceding and succeeding are very much close, like this. Here it is in the case of here, 36 is the maximum here, but next to the 35 is also here. Next to 20. So here very much near. Here you can apply the inspection method. When the maximum are very much near to each other, you can apply the inspection method to find out which one is the more, because you have to follow this definition. In that case, you have to follow this. The more can be thought of as the value about which the items are most closely concentrated. The first definition is which occur with the greatest frequency. Which occur with the greatest frequency. Okay, there was by inspection. Now, more can be thought of as the value about which the items are most closely concentrated. In that case, when in such cases you have now 36 and 35 are very much close. So you can't say 20 is the more, because 36 is the maximum. In such case, you have to apply grouping table and analysis table. And it's a lengthy process. Grouping table and analysis table you have to apply. Now you assume that 36 is maximum. Here it seems that 20 is the more. But by applying the grouping analysis table, you may find that here. You may find it. Hence, the model value is 25. Not the model value is 25. Not the 36. Not the 20. Maximum 36, so 20 should be the more. But since nearby there is a maximum concentration is there, nearby there is also a concentration. So by following the grouping table analysis table, ultimately what we found is that the model value is 25, not the 26, not the 20. It is the 25. So when you find it that the frequencies are very much close to each other, maximum frequencies are very much close to each other, then go for grouping table and the analysis table. Now, then you should know how to calculate standard deviation, because without the knowledge of standard deviation, even though arithmetic means are same, you can't draw the conclusion whether the series are having uniformity or not. In two series, when you make the comparison, the lesser the standard deviation, you say that the series having the lesser value of standard deviation is more uniform. In a particular school, you may find that all are getting above 80, and the standard deviation is say around say, the standard deviation only 3. But in some school, you may find that the standard deviation is around 20. So in a school where the marks secured by the students variation is very less among themselves, so this school may be considered as a good school having good students. But here in some other school, you may find that marks variation among the students may be around 30%. That means there are good students are also, but there are worse students were also there. The students are not uniform. So by looking at the standard deviation, we can come to the conclusion that is whether the values of the variables are uniform or not. So standard deviation plays a very important role. And again, as I have said that while regarding the metric data that you have collected in the quantitative basis, what you have to do is you can compare about the arithmetic mean, whether the mean income or mean stress, or whether there is significant difference among the region, among the teachers, among the male and female, and so on. Among the different designation, you can do it, or correlation. Whether correlation, see, correlation gives you multiple correlation, or correlation gives you the joint contribution of all the variables. But your regression analysis will give you the individual contribution of the variable. Once you find the correlation, then you can go for regression. But in the regression analysis, it will give you the individual contribution of all the variables. But in the correlation, there was a joint contribution. So with these few words, let me conclude for the first session. And after having a break of 5 to 10 minutes, let's begin for another session. There will be a testing of hypothesis. Over to Divjyoti, sir.
Yes, sir.